Good morning students, welcome back in e-learning videos of physics. In our earlier lecture, we have seen the point, the resolving power of microscope. But in today's lecture, we are going to see the simple point, resolving power of a telescope. The same condition in between the resolving power of microscope and resolving power of telescope. We know that what is meant by microscope and what is meant by telescope. We know that the microscope means microscope is an optical device which is used to see the smallest object clearly, but telescope is an optical instrument which is used to see the distinct object clearly, means the object which are placed at a large distance, and if you want to see this object, then we have to only use the telescope. Means a telescope is an optical instrument which is used to see the distinct object clearly is called as a telescope. Then next one, what is meant by the resolving power of telescope, right? Resolving power of telescope is defined as the reciprocal of least angle subtended at the object by the two distinct points objects which can be distinguished just resolved to its final focal plane of the telescope. We know that this is the least angle, this is the least angle, this is the least angle. We know that the object is placed at infinite distance. The object is not placed at finite distance, but the object is placed at infinite distance, and the object made the least angle, right? The resolving power of telescope, again we will define what is meant by resolving power of telescope. The resolving power of telescope is defined as the reciprocal of least angle subtended at the objective by the two distinct objects which can be distinguished to just resolved in the focal plane of the telescope. This is the objective. We know that this is the objective. This objective lens AB is the objective lens, and this objective lens make an least angle d theta to two objects which is called as d theta. D theta is the least angle subtended by objective to that two objects which are placed at infinite distance, right? त्याच्यामध्ये आपल्याला काय बघायचं आहे बघा की रिझॉल्विंग पॉवर ऑफ टेलिस्कोप बघायचे आहे. मग टेलिस्कोप म्हणजे काय किंवा टेलिस्कोप आपण काय यूज करतोय, तर जर काही ऑब्जेक्ट्स किंवा काही ऑब्जेक्ट्स हे जर लार्ज डिस्टन्स वरती प्लेस झाले असतील, फॉर एक्झाम्पल स्टार असेल, गॅलेक्सीज असतील किंवा डिफरंट पॉइंट्स असतील, तर हे पॉइंट्स किंवा ह्या गॅलेक्सीज किंवा हे स्टार्स किंवा सन हे जर आपल्याला ऑब्झर्व करायचे असतील तर सनला आपण टेलिस्कोपने ऑब्झर्व करू शकत नाही. फॉर एक्झाम्पल आपण स्टार घेऊ शकतोय, फॉर एक्झाम्पल आपण गॅलेक्सी घेऊ शकतोय, वेगवेगळे पार्ट घेऊ शकतोय. याच्यामध्ये जर ऑब्झर्व करायचं असेल तर त्यावेळी जे डिव्हाइस आपण यूज करतोय त्या डिव्हाइसला आपण काय म्हणतोय, टेलिस्कोप. म्हणजे दूरवरचे ऑब्जेक्ट जर क्लिअरली बघायचे असतील तर आपण काय यूज करणार आहे, टेलिस्कोप यूज करणार आहे. ओके. त्याच्यानंतर इथे आपल्याला दिसतंय की जे ऑब्जेक्ट तुम्ही कन्सिडर केले ते इनफायनाइट डिस्टन्स वरती आहे, मात्र त्या ऑब्जेक्टची जी विड्थ आहे ती आपण काय कन्सिडर केली आहे, a. म्हणजे दोन ऑब्जेक्ट मध्ये जे डिस्टन्स आहे ते आपण काय कन्सिडर केला आहे, स्मॉल a कन्सिडर केला आहे. त्यानंतर आपल्याला दोन पाथ दिसतात, एक आहे तो डॉटेड पाथ आणि दुसरा आहे तो सॉलिड पाथ. तर याच्यामध्ये pq हे जर ऑब्जेक्ट असतील तर त्यांच्या रिस्पेक्टिव्ह इमेजेस काय असणार आहेत, p1 आणि q1 असणार आहेत. बघा की जे ऑब्जेक्ट आपण कन्सिडर केले की जे इनफायनाइट डिस्टन्स वरती आहे ते जर p आणि q असतील तर त्यांच्या रिस्पेक्टिव्ह इमेजेस काय असणार आहेत, p1 आणि q1 असणार आहेत. तर आपण बघूया व्हॉट इज मीन बाय रिझॉल्विंग पॉवर ऑफ टेलिस्कोप. परत आपण बघतोय ए टेलिस्कोप इज अन ऑप्टिकल इन्स्ट्रुमेंट which is used to see the distinct object clearly. right? Second one, the resolving power of telescope is defined as the least angle subtended by at the objective by the two distinct objects which can be distinguished just resolved in the focal plane of the telescope, right? In given diagram, we know that we have not seen P and Q, but we have to consider these P and Q are placed at infinite distance. Therefore, we have to consider P and Q be the two distinct objects. The objects are placed at infinite distance, right? You have to consider the P and Q are two distinct objects observed through telescope. Then the objective lens of the telescope produces the diffracted images of that points objects in its focal plane. We know that. Here we have to consider the 2 point objects P and Q, which is placed at infinite distance, and these point objects can see by using telescope, and the objective placed this objective gives the diffracted images of that telescope to the focal plane of objective. म्हणजे आपण काय म्हणायचं बघा की जे पॉइंट ऑब्जेक्ट्स आहेत जे कन्सिडर केलेले आहेत ते इनफायनाइट डिस्टन्स वरती प्लेस्ड केलेले आहेत आणि मग त्या ऑब्जेक्टला आपण कशातून बघतोय टेलिस्कोप मधून बघतोय आणि मग त्यांचे ज्यावेळी रेज येतील किंवा त्या ऑब्जेक्ट ज्यावेळी पास आउट होतील त्यावेळी त्यांची डिफ्रॅक्टेड इमेज आहे त्या पी आणि क्यू हे जे पॉइंट ऑब्जेक्ट आहेत त्यांची जी डिफ्रॅक्टेड इमेज आहे ते आपल्याला कोण देतं हा ऑब्जेक्ट देतो आणि ही कुठे मिळते आपल्याला तर फोकल प्लेन ऑफ दॅट लेन्स भेटते राइट वी नो दॅट लेट p1 and q1 be the position of the central maxima of two images. आता इथे आपल्याला ही इमेज भेटते p1 आणि q1 या त्या दोन पॉइंट ऑब्जेक्ट्स आपल्याला काय भेटले इथं इमेज भेटले. त्यानंतर आपण कन्सिडर करतो याच्यामध्ये डिफरंट फॅक्टर्स आहेत. इथं d थीटा आहे. d थीटा म्हणजे आपण काय म्हणू शकतो d थीटा इज द angular separation or angular separation between the two distinct objects p and q. हे जे आहे हे angular separation आहे ते जे दोन distinct objects आहेत त्यांच्यामध्ये काय आहे angular separation. त्यानंतर d थीटा आपण बघितलं. त्याच्यानंतर आपण बघणार आहे a म्हणजे काय. a म्हणजे काय असेल तर अपर्चर ऑफ द ऑब्जेक्ट. A means काय असेल अपर्चर ऑफ द ऑब्जेक्ट. त्यानंतर किंवा अपर्चर ऑफ द ऑब्जेक्टिव्ह लेन्स आपण त्याला असं म्हणू शकतो. नेक्स्ट लॅम्डा इज द वेव्हलेंथ ऑफ लाईट यूज्ड. म्हणजे पहिल्यांदा आपण बघितला d थीटा. त्यानंतर आपण काय बघतोय स्मॉल a बघितलं अपर्चर ऑफ द लेन्स. त्यानंतर लॅम्डा वेव्हलेंथ ऑफ लाईट यूज्ड आणि लास्ट पण आपण बघतोय f म्हणजे फोकल लेंथ ऑफ दॅट लेन्स. जी लेन्स आपण इथे यूज केली त्या लेन्सचा f हा काय असेल फोकल लेंथ असेल राइट. मग अकॉर्डिंग टू रेलेव्हन्स क्रायटेरिया आपण काय म्हणू शकतो तर ऑब्जेक्ट p आणि q आपल्याला माहित आहे आणि त्याचे रिस्पेक्टिव्ह इमेजेस आपल्याला मिळालेले आहेत p1 आणि q1 राइट. मग अकॉर्डिंग टू रेलेव्हन्स क्रायटेरिया द टू इमेजेस p1 and q1 आर सेड टू बी जस्ट रिझॉल्व्ड. आणि ही कंडिशन आहे आणि ही कंडिशन सॅटिस्फाय व्हायला पाहिजे कारण मिळणाऱ्या इमेज ह्या क्लिअर मिळायला पाहिजेत आणि जर इमेज क्लिअर मिळायला पाहिजे असतील तर काय कंडिशन सॅटिस्फाय व्हायला पाहिजे बरोबर. म्हणून आपण असं म्हणू शकतोय अकॉर्डिंग टू द रेलेव्हन्स क्रायटेरिया द इमेजेस p1 and q1 आर सेड टू बी जस्ट रिझॉल्व्ड इफ द इमेज p1 coincide the maximum the central maximum of the image p1. The central maximum of image p1 must be coincide with the first secondary minimum of q1. म्हणजे दोन इमेज हे आपल्याला क्लिअर पाहिजे असतील किंवा जस्ट रिझॉल्व पाहिजे असतील तर p1 चा सेंट्रल मॅक्सिमम हा q1 च्या फर्स्ट सेकंडरी मिनिमम वरती काय व्हायला पाहिजे मॅच व्हायला पाहिजे राइट. कोइन्साइड व्हायला पाहिजे means according to Reynolds criteria the two images p1 and q1 are said to be just resolved if and only if the central maximum of p1 must be coincide with the first secondary minimum of Q1, then these two images are said to be just resolved, right? म्हणजे P1 आणि Q1 ह्या जर क्लिअर इमेज आपल्याला पाहिजे असतील, जस्ट रिझॉल्व जर पाहिजे असतील, तर त्यावेळी P1 चा सेंटर मॅक्सिमम हा Q1 च्या फर्स्ट सेकंड रिव्ह्यू वरती काय व्हायला पाहिजे, मॅच व्हायला पाहिजे. मग ही कंडिशन सॅटिस्फाय जर व्हायची असेल म्हणजे P1 चा सेंटर मॅक्सिमम हा Q1 च्या फर्स्ट सेकंड रिव्ह्यू वरती जर मॅच व्हायचा असेल तर आपल्याला काय करता आलं पाहिजे, काय कंडिशन सॅटिस्फाय व्हायला पाहिजे. आणि ती कंडिशन काय आहे बघा, द कंडिशन इज सॅटिस्फाइड व्हेन द पाथ डिफरन्स बिटवीन टू एक्स्ट्रीम रेज P and Q इज लॅम्बडा. जे दोन रेज आपण कन्सिडर करतोय, दोन डिस्टिंक्ट ऑब्जेक्ट पासून P आणि Q पासून, तर हे जे दोन एक्स्ट्रीम रेज आहेत याच्यामधला पाथ डिफरन्स हा किती असायला पाहिजे, लॅम्बडा. तरच P1 चा सेंट्रल मॅक्सिमम हा Q1 च्या फर्स्ट सेकंड रिव्ह्यू मध्ये काय होतोय, मॅच होतोय, राईट. According to Bayes' criteria, the two images P1 and Q1 are said to be just resolved if the central maximum of P1 must be coincide with first secondary minimum of Q1. Then the two images are said to be just resolved. And this condition is satisfied only when the two extreme rays coming from P and Q having path difference lambda, right? This is the simple condition. We know that in the figure AC is the normal dot on the rays coming from the source and BC is the path difference. This BC is the path difference and we have to draw a normal from A to that ray, right? BC is the path difference and AC is the normal drawn to that line. But when you have to consider the path difference or when you have to consider the geometry of the figure, then the path difference BC, the path difference BC, you have to consider the geometry of the figure. BC is equal to AB sin d theta. AB sin d theta. You have to consider is equal to lambda. Right? Actually, it is BC upon AB is equal to sin d theta. We have to define sin d theta. Sin theta means opposite upon hypotenuse. Right? Hypotenuse is this, and this is means we have to consider small a. Right? This is BC is equal to A into sin d theta. A into sin d theta. But AB is equal to small a. Therefore, this is nothing but diameter of the lens when we have to consider the angle is very small, and when the angle is very small, then we have to consider sin d theta is nearly equal to only d theta, and then you have to replace d theta by sin d theta by only d theta, right? Then we know that the path difference BC is equal to A into d theta. This will consider lambda. This is also lambda. Then BC is equal to A into d theta is equal to lambda. This is the simple equation, but we must consider d theta is equal to lambda by A. D theta is equal to lambda by A. Equation number 2. This equation number 1. This is equation number 2. These are the two simple equations. But we know that in case of telescope, the objective base is circular aperture. We have to consider two types of aperture: circular aperture, and second one is the first is the circular aperture, and we have to consider another aperture, maybe cylindrical aperture or any other aperture. And when you have to consider a circular aperture, then we have to multiply it by 1.22 into lambda, right? If here we have to use the lens and the aperture of lens is circular, then we have to multiply this term to 1.22. Therefore, d theta, if the aperture of objective is circular, then d theta is equal to 1.22 into lambda divided by small e. This is the term. But according to scientist array, we have to consider, according to scientist array, d theta is equal to 1.22 into lambda by a. This is the simple term. According to array, we have to also consider d theta is equal to 1.22 into lambda by a. This is the limit of resolution of a telescope. The above equation number 3. The equation number 3 indicates the limit of resolution of the telescope. Equation number 3 indicates the limit of resolution of a telescope. Right? Then we have to define again resolving power of telescope. What is meant by resolving power of telescope? The resolving power of telescope is defined as it is the reciprocal of limit of resolution. Right? We have to define resolving power of telescope is defined as it is the reciprocal of limit of resolution, because in this point d theta is nothing but limit of resolution. Therefore, resolving power is equal to 1 upon, what is the term, 1.22 into lambda divided by a. Therefore, final term is resolving power is equal to a divided by 1.22 into lambda. This is the resolving power of telescope. This is the final equation of resolving power of a telescope. Again, we know that here we have to see the resolving power of telescope. We have to see again what is meant by resolving power of telescope. First, we have to define what is meant by telescope. Telescope is an optical instrument which is used to see distinct objects clearly. Then second one, we have to define what is meant by resolving power of telescope. The resolving power of telescope is defined as the reciprocal of the least angle subtended at the objective by the two distinct point objects which can be distinguished as a just resolved in the focal plane of a telescope. Then explanation of this simple diagram. Here we have to consider the objects P and Q, the point objects P and Q which are placed at infinite distance. Here we have to not see these point objects P and Q, but we have to place these objects at infinite distance. Therefore, let P and Q be the two distinct objects observed through the telescope. The objective lens of the telescope produces the diffracted images of the objects in its focal plane. Right? Then P1 and Q1 be the position of the central maximum of two images. Here we have to see this is the images. P1 and Q1 are the respective images of the 2 point objects P and Q which are placed at infinite distance, and these images can be observed through telescope when that point objects images can be diffracted from the objective lens. Then we know that d theta is the least angle subtended by these two objects. This objective to that point objects A aperture, then lambda is the wavelength of light used, then f is the focal length of objective lens. The next one, according to analysis, we know that there are 2 point objects and the respective images of that point objects are P1 and Q1. Then according to analysis, these 2 images P1 and Q1 are said to be just resolved if the central maximum P1 must be coincide with the first secondary minimum of Q1. At that time we have to say that the 2 images are said to be just resolved. Right? But this condition is satisfied only when the path difference between two extreme rays coming from P and Q must be equal to lambda. Therefore, we have to draw a perpendicular from the A to that line. Therefore, BC is act as a path difference, and this is the angle subtended by objective to the 2-point objects. Therefore, we have to use geometry of the figure. Sin theta is equal to BC upon AB, and then we will get the BC is equal to AB sin theta is equal to lambda, because we have to first consider a path difference is equal to lambda. Therefore, BC is equal to, instead of AB, we have to use small a. This is AB, we have to use small a. Therefore, BC is equal to A sin d theta is equal to lambda. But sin theta is very small. Therefore, sin d theta is nearly equal to d theta. We have to replace sin by d theta. Therefore, BC is equal to A into d theta is equal to lambda. Therefore, d theta is equal to lambda upon A. Question number 2. But if the aperture of the object is circular, then we have to multiply it by 1.22. Then d theta is equal to 1.22 into lambda by small a. According to array, this is also term d theta is equal to 1.22 into lambda divided by small a. But we have defined limit of resolution. But what is the resolving power of telescope? The resolving power of telescope is 1 upon limit of resolution, because in case of telescope, d theta is the limit of resolution. Therefore, resolving power of telescope is equal to 1 upon d theta. Resolving power is equal to 1 upon 1.22 into lambda divided by small a. Therefore, finally we have to get resolving power of telescope is equal to A divided by 1.22 into lambda. This is the simple equation for resolving power of telescope. Right? So this chapter is over. This is the last point in that chapter. We have to start the chapter wave optics, and this chapter is covered with all points. Then some problems are covered. Then we have to take another one lecture for a problem, and then this chapter is totally covered. Thank you.